So completing the square, this is a technique very much like factorising into sets of brackets, which allows you to solve quadratic equations and rewrite quadratic expressions. Just a quick note before we get started, essentially you're only going to use this technique when the question calls for it. So if the question says leave your answer in the form and then it's a completed square form, or if the question says solve this by completing the square, then obviously you're going to use completing the square. But more often than not, it's going to be a lot easier to use the quadratic formula as a method of solving quadratic equations that don't factorise rather than completing the square. So just running you through the structure of this video, section 1 we're going to be looking at the basic principles of completing the square and then the basic examples. Part 2 of this video we're going to be looking at the case where fractions are going to be involved inside your set of brackets once you've completed the square. Part 3 of the video we're going to be looking at solving equations through completing the square, and then part 4 we're going to be looking at the more difficult example where there's a number that isn't 1 in front of your x squared term. So you might have 4x squared, 5x squared, etc. So let's make a start. Basic principles. If I have this, okay, x plus 2 squared, you know this expands out to x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4. So just bear with me a second. And if we do x plus 3 squared, this is going to be the same as x squared plus 3x plus 3x plus 9, or x squared plus 6x plus 9. So if you take a look at the relationship between this number here, so these are both involve a term in x and a number term in each of these sets of brackets. And if you take a look at the relationship between the number in the brackets and say this term here, so how do you go from 2 to 4? Well, 2 is just half of 4. Similarly here, if I have x plus 3, how do I go from here to here? Well, I double my 3 to give me my coefficient on x, my 6 here. Or alternatively, if I want to go back from there to there, it's obviously going to be half. So similarly, if I had x plus 4 all squared, well, you know your first term is going to be x squared. What's my term in x going to be? Well, I've got a plus 4 there, so it's going to be plus 8x. Now, going back to our first two examples here, looking at our number term, you notice, how do I go from here to here? Well, I could double it, but that's not what we actually do. How do I go from here to here? I actually square my number term to give me my number term, my constant term in the final expanding expression. So square this one to give me 4, square this one to give me 9. What's my number term going to be here? Well, if I square this, it's going to be plus 16. And then just one example. So if this is now a negative, what happens? Well, I have x squared, double my minus 5 to give me minus 10x, square this to give me plus 25. Okay, so we're going to use these principles in helping us to complete the square. Completed form square looks like this. So I'm going to have x, which stays my x, plus or minus a number, which we're going to call a, all squared, minus b. Okay, this is always going to be a minus, or largely speaking, it's going to be a minus. And this could either be a plus or a minus. Right, so completing the square, it involves rewriting quadratic expressions. Okay, so this is my original quadratic expression, x squared plus 8x, and I need to get it in this form here. Okay, I'm going to put a little bubble, little Michael Bublé around that. X plus a squared minus b, and I need to rewrite this in this form here. Okay, so I'm going to have x plus or minus a number all squared minus another number. Right, so if I'm looking at this, what does this number here need to be to give me a coefficient of plus 8? Well, it has to be plus 4. It has to be half of that coefficient, because you know if you expand this set of brackets out, I'm going to have x squared plus 4x plus 4x plus 16. So I will have 8 x's in this, if I were to expand this whole thing out. But if you take a look here now, yes, I have that plus 16 term hanging around. So you know this expands out to this. So this plus 16 term would just be hanging around. You notice this plus 16 term is not in our original expression there. So if I were to expand this out, I need to get rid of this plus 16 term. How do I do that? Well, I quite simply subtract 16. Okay, so that's rewriting our first expression there in completed square form. Okay, so you notice I do indeed have x plus or minus a number. In this case, our a is positive 4. And then here our b term is 16. Second example we're going to look at, well, what happens now if I have this? And my original expression has a number term included in it. Well, it needs to be in this form where I have x plus or minus a number and then plus or minus another number out here, similar to this expression up here. But in terms of getting to my coefficient on x here, does this term in the brackets change? Well, no, it doesn't. Okay, because if I were to expand this out, I would have x squared plus 8x plus 16. Okay, so in terms of getting us to our coefficient on x, or the correct coefficient on x, that's absolutely fine. But again, I have this plus 16 term that I need to get rid of. Okay, minus 16. And this minus 9 term, it just stays there. Okay, because if you take a look at this expression here, we know that that expression there is the same as this expression here. We've shown that up here. So if you're comparing this, how do I change this expression on the right hand side that I've underlined to make it the same as this whole expression on the left hand side there? Well, the only difference is that I've got a minus 9 here, and I also need a minus 9 there. The easiest way to think about it is if you have a number hanging around by itself, okay, complete the square for these two terms here, i.e. your quadratic term and your linear term, which is what we've done here, and then just move that number over. So we've got minus 9 there and I have minus 9 there. And then tidying that up, so we need it in this form here where I just have a single constant hanging around by itself. At the moment we have two rude boys hanging around outside, so we need to combine those. Minus 16, minus 9, same as minus 25. Okay, let's go through one more example. This is going to be an example where our coefficient on x is negative. Okay, so it's going to be in this form here. In terms of getting to this expression here, what do we need to do? Well, it's going to be x, it's going to be minus 5. Okay, half of this term here is minus 5, or half of the coefficient there is minus 5. So if I were to expand that out, I would get back to that, and we will prove that in just a second. Okay, but remember, you need to deal with the constant term that results when I expand those brackets out. Okay, so essentially just completing the square for these first two terms to begin with. Well, I need to negate this. Oh, sorry, that's going to be a positive. I need to negate this plus 25. How do I do that? I need to subtract 25. So those two expressions there, x squared minus 10x is equivalent to x minus 5 all squared minus 25. And I just need to deal with this constant term here. I've got a plus 8, so I need plus 8 here. And now lastly, tidying up, x minus 5 squared, well, minus 25 plus 8, what do I have all together? I've got minus 17. Okay, so that is the completed square form for the expression on the left hand side there. Part 2, dealing with fractions. So up until now we've looked at the case where our coefficient on x, i.e. our linear term, has been a even number. But what happens if it's an odd number? What happens if I have something like this? Okay, you can see there that when I try and put this into brackets, okay, half of 7 gives me a fractional answer, gives me a non-integer value. Let's express this as 7 over 2. You know that's 3.5. So this would be our first step, as was the case when we had an even coefficient on x. Now, what do I need to subtract in order to get back to this expression here? Well, if I expand this out, so I've got x plus 7 over 2, let's do this in full, multiplied by x plus 7 over 2. Obviously this is going to give you to x squared plus 7 over 2x plus 7 over 2x plus, now if I multiply this by this, it's going to give me 49 over 4. 7 over 2 times by 7 over 2 is me 49 over 4. Right? So that's the same as x squared plus 7x plus 49 over 4. Just remember, to begin with, we're only looking at these two terms here. Essentially, we're completing the square for those two terms. So if you're comparing this to this, how do I get from here to here? Well, I need to subtract 49 over 4. Okay, and that's always going to be the case. So if you think back to our previous examples, here, I mean, notice our the thing that we would subtract to get back to our squared term and our linear term was just whatever's in this bracket squared. Okay, so here 4 squared gives me 16, I need to subtract 16. Similarly here, minus 5 squared is 25, so I need to subtract 25 to get back to my original, the first two terms of my original expression there. Similarly here, what do I subtract? I've got 7 over 2 here. I need to subtract 7 over 2 squared, i.e. 49 over 4, to get me back to those first two terms there. But I still have this constant term hanging around, and subtract 4 from both sides, or sorry, subtract 4 from the right-hand side there, such that these two expressions are now equivalent. And then again, last step, we need to tidy up these two constant terms because I need it in the form x plus a all squared minus b, i.e. where this number here is just a single constant term, a single number. So this all stays the same, and now I have minus 49 over 4, just dealing with my fractions, minus, what's this as a fraction over 4, it's 16 over 4. Oh, steady. So this all stays the same. Minus 49 over 4 minus 16 over 4 gives me minus 65 over 4, and that can't be cancelled, so that is my final answer. So that's dealing with fractions, essentially exactly the same, but you just need to be careful here where you're squaring your the number term in your brackets. If it's a fraction, it's going to look like this. So you need to square the top, square the bottom to give you the squared form of that fraction there. So part 3, as promised, we're going to look at solving equations using the completing the square method. Our first equation that we're going to look at is this one here, x squared plus 12x plus 5 equal to 0. So on first inspection, you might try and solve this by factorisation. So you might try and factorise the left-hand side there into two sets of brackets, and you realise it wouldn't go. But this is going to be clearly signposted in the final exam. If they expect you to solve this by completing the square, they will either say leave your answer in surd form, leave your answer in exact form, in which case you can use either the quadratic formula or the completing the square method, or they'll quite simply say solve this by completing the square, in which case you're required to use the completing the square method. Right, so what we're going to do, we're going to complete the square for this expression on the left-hand side. So, I mean, really, you could move this plus 5 term over to the right-hand side to begin with. It's not really going to make one iota of difference whether you do that first or whether you do that later on. I'm not. So we're just going to complete the square for that expression on the left-hand side. So you know it's going to be this form here, and you're going to have a number hanging around here. Well, remember, looking at these first two terms to begin with, how do I get what goes in here to give me my plus 12x? It's got to be half of that coefficient on x, half of that 12, which is 6. Okay, what do I need to subtract to get me back to that original expression? Well, you know, if you expand this set of brackets out, I have x squared plus 12x plus 36, so I have to subtract that 36. Okay, and then that plus 5 just stays as is, equal to 0. Now tidying that up, I have x plus 6 all squared and minus 36 plus 5, so it's exactly the same as we've been doing in the previous section of the video. Minus 31 equals 0. Okay, now this is where our differences arise, or rather this is where our additional steps can be found. X plus 6 all squared, I'm going to move this term over to the right hand side. Just notice this term here, it will always be negative, and I'll show you why in the next, it will always be negative, and I'll show you why in this next step here. Equal to 31. So this step here, notice there are two operations being performed on x on the left hand side. So you know your answer is going to be x equal to something. We need to work out that x. So in order to do that, we need to undo both of those operations that are being done to our x. So at the moment 6 is being added to it and it's being squared. We need to work outside in. That's the way you want to think about it. Working outside in, so I need to undo this square term to begin with. How do I do that? I'm going to square root both sides. I square root both sides. Square root of 31 is not an integer value. I can't work that out. Just remember, you need to do this. Plus or minus 31. So this is where a lot of students will lose marks. They forget that when you square root a number, essentially there are two answers to that number, the positive and the negative square root. So say I have this, 4. Okay, what's the square root of 4? Or sorry, what squared gives me 4? Well, 2 squared equals 4. So does minus 2 squared. That also gives me 4. Okay, minus 2 times minus 2. Negative times by negative will give me a positive. So when you square root both sides here, you need to make sure that you've got this plus or minus sign. Okay, so this step here, when I was saying that this number here needs to be negative, the reason that is because when you bring it to the other side, it's obviously going to become positive, and you can only have the square root of a positive number. You cannot have the square root of, say, negative 4. There are no real numbers which will give me, which will satisfy this, okay? Obviously, 2 squared equals 4, minus 2 squared equals 4. A number times by itself cannot give me a negative number. Okay, so that's why this term here needs to be negative. Now, one more thing to do here. I've got x plus 6 equal to plus or minus square root of 31. I need to undo this plus 6 on the left hand side. How do I do that? Subtract 6 from both sides. Okay, and try to leave your answer like this. That's the most conventional way of writing it. So I've got, essentially I'm subtracting 6 from the right hand side there. So I've got minus 6 plus or minus the square root of 31. So that's the first example all solved. Let's take a look at one more example. We're going to have x squared minus 3x equal to positive 3. So you notice here a couple of observations. You're looking at the equation that we're presented with here. Number one, this term here, our coefficient on x, is not even, it's an odd number, which means that when we're completing the square, we're going to have a fractional term inside of our brackets. Number two, you compare this to our previous equation here, we had all of our terms on the left hand side. Here we have one term on the right hand side. You can actually just leave that there, but essentially just so long as you're following the standard rules of equations, most fundamental rule of them all being the fact that whatever you do to the left hand side, you also need to do to the right hand side, and that will ensure that you maintain the value of the variable in the equation. So you could move this 3 over to the left hand side, so you could subtract 3 from both sides, leaving you 0 on the right hand side, but that's not really going to speed things up. Similarly here, you could have subtracted 5 from both sides as your first step, and all that would happen is this 5 would disappear. You'd have minus 5 on the right hand side, but your answer would come out exactly the same. It's just so long as you're doing the same thing to both sides of the equation, you will maintain the value of the variables in that equation, which is what you want. So to begin with, we're going to complete the square for this expression on the left hand side. So it's going to look like this: x plus or minus a number all squared. What's that number going to be? How do I get to here? What's half of minus 3? It's minus 3 over 2. And in terms of what we need to subtract to get back to this original expression on the left hand side there, Well, I need to subtract 3 over 2 squared, i.e. subtract 9 over 4. Okay, so now this expression there is the same as this expression there, equal to 3. Next step, I'm going to move this number term over, so I need to add 9 over 4 to both sides. Okay, what's this? 3 as a fraction over 4, it's 12. Which equals 21 over 4. Now what do I need to do? So I've got x minus 3 over 2 all squared equals 21 over 4. So I need to undo the two operations. I need to undo this square term. Also need to undo this minus 3 over 2. Remember, working outside in, undo this squared term to begin with. X minus 3 over 2 equals the square root of 21 over 4, and remembering one of the most important points here, it needs to be plus or minus the square root of 21 over 4. And just notice here that I could rewrite this, I could rewrite that as the square root of 21 over 2, because you can work out square root as a numerator and the square root as a denominator separately, but it's not entirely necessary unless the question specifies. And then lastly, how do I undo this minus 3 over 2? Well, I'm going to add 3 over 2 to both sides. So the final answer, x equals 3 over 2 plus or minus the square root of 21 over 4. Okay, the last part of this video, we're going to be looking at the case where your coefficient on x squared isn't 1, i.e. you're going to have 4x squared, 3x squared, 5x squared, etc. So let's take a look at this one. 2x squared minus 4x minus 6 equal to 0. First step, you want to look at these two terms and you need to take out a factor, and that factor is going to be the coefficient on your x squared. So here, use square brackets, and you'll see why in just a second. Remember, we're only looking at these first two terms, factorising these first two terms, and the number that you take out is always going to be the number in front of your x squared. Even if this number here was 7, okay, and 2 is obviously not a factor of 7, you'd still take out a factor of 7. So essentially, if you had that, you were taking out a factor, it would look like this, okay, and that's what you would have to do. Okay? The number that you take out, the number that goes in front of your brackets here, sorry, those should be square brackets, is always going to be the coefficient on x squared, the number in front of x squared. So, doing that, factorising, how many lots of 2 go into x squared, sorry, 2x squared, what's x squared goes x squared times. How do I go from here back to here? Well, I need to minus 2x. So that's our first step. We've taken out this coefficient out of the first two terms there. Second step, the reason why we need to leave this in square brackets here is because we're going to complete the square for that expression there. Okay, so completing the square, you know, it's going to look like this, plus or minus number all squared. So how do I go from here to here? It needs to be half of that, so it's going to be x minus 1 all squared. How do I go from here back to here? Well, I need to subtract 1 to make this expression in the square brackets here equivalent to this expression in the square brackets here. Minus 6 just stays the same, equal to 0. Okay, next step here. For this one, you could actually divide both. You could just divide both sides through by 2, because this term here is divisible by 2. But generally speaking, what you can do is this. So we're just going to move this constant term over to begin with. Okay, so add 6 to both sides, gets rid of the minus 6 here, positive 6 here. Now, again, working from outside to in, I need to undo all of these operations that are happening to my x there, our lonely x. First of all, let's divide both sides by 2 to get rid of this 2. So at this point, I can get rid of my square brackets because I only have one set of brackets there. So dividing both sides by 2 leaves me with 3 on the right hand side. So all I'm doing is actually getting rid of that 2, dividing the right hand side by 2. And now this equation here looks familiar. We know what to do when we're presented with a situation here. We need to undo this minus 1 first, undo that squared term, and then undo this minus 1 term here. So how do I undo this minus 1? Move it to the other side. I add 1 to both sides. 4 on the right hand side. How do I undo the square term? Oh, don't need that anymore. How do I undo the square term? Square root both sides. Remember, it's going to be plus or minus the square root of 4, i.e. plus or minus 2. And then lastly, how do I undo this minus 1? I add 1 to both sides, so my final answer is going to be 1 plus or minus 2. And you can actually work these out. So either x is going to equal, so 1 plus 2 gives me 3. And x equals 1 minus 2, which equals minus 1. And if you were to put those into the left-hand side of the equation there, i.e. substitute x equal to 3 into this, substitute x equal to minus 1 into this expression on the left-hand side there, you would indeed get 0 on the right-hand side. That's the first example we're going to look at. The second example is slightly more difficult, so let's go for this one. 3x squared minus 12x equal to 3. So you notice differences between this equation here and this equation here. Principally the fact that here on the right hand side you have 0, on the right hand side here you have this number term. I'm actually just going to leave that number term there. And working on your quadratic term and your linear term, you need to take out a factor. So this is where you introduce your square brackets. This is where you take out this coefficient on x squared out of these two terms. So it leaves me with x squared minus 4x. So completing the square for this one here, I get 3 brackets x minus 2 all squared minus 4 equal to 3. So just remember, how do you get this number term in here? Well, it's got to be half of this coefficient on x here. Half of minus 4 gives me minus 2. How do I get this term here? Well, it's always going to be negative, and it's just this number term here, so minus 2 squared, which gives me 4. It needs to be minus 4. It's always going to be negative. Now, what do I do here? Working outside to in, divide both sides by 3. X minus 2 all squared minus 4. Dividing the left-hand side by 3, this 3 disappears. I'm left with this. Dividing the right-hand side by 3, I'm left with 1. It's minus 2. Undoing this minus 4, add 4 to both sides. It's going to be 5 on the right-hand side, x minus 2, so square rooting both sides, plus or minus the square root of 5, and then adding, so don't really need those brackets there. Adding 2 to both sides there leaves me with my final answer, which is x equals 2 plus or minus the square root of 5. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.